Okay, it's Tuesday. It's 1 o'clock Central Time. Welcome everybody to our uh, to this week's HDF Clinic. And yeah, I checked before the meeting. There weren't any questions in our Google document. So, but that doesn't mean there aren't any questions. So I'm going to pause and ask for those who were able to join here today. Are there any questions?
Gerd, I just had one quick one, and maybe
Sure.
we can defer it till next week because I didn't have a chance to submit it on your on the document. But it had to do with a question that came up with the split file driver.
Okay.
We touched on a little bit with your diagram last week, but I was curious about the interactions between those VFDs and something like the split file driver. And I guess specifically, if I use a split file driver or and create the multiple files for the metadata and the data,
Mm-hmm.
that sounds great. And I get the performance that I want. But do I have any options of moving the data file that I split out onto network storage? In other words, I think what I'm asking is there a way to put that up on S3? You see what I'm saying? So I really have this data storage agnostic view when I look at my HDF5 file from the root on down. Does that make any sense, or am I in yellow card territory?
A great question. So I will maybe come back to this question next time, but I will say a few things right now, but then maybe come back.
Okay.
So, right. So the good news is, yeah, with these VFDs, such as the split VFD, yes, you would be, this is not shown in the picture here. You can stack some of these VFDs, these virtual file drivers. They are stackable in the sense that, yeah, you can put one on top of the other. And so the split VFD is actually an example of a VFD that basically looks at I/O requests, reads and writes, and basically looks at the VFD level. You can sort of see whether a read request or write request is for what's considered file level metadata or file level raw data, and then can sort of funnel them in separate streams, if you wish, to another VFD, such as the SEC2, the POSIX VFD, and so forth. And yes, that's what's happening with the split VFD. Now, so as you rightly say, okay, as a result, you will have two files. Let's say you're writing this to a file system. You will have two files, and one of the files will contain the, let's call it the non-metadata, because, yeah, the term raw data is maybe a little misleading. The non-metadata, and then the other file, typically a smaller one, contains the metadata. Now, my recollection is that these pairs, they have to move in tandem, in the sense that you cannot, at least if you want to use the HDF5 library to access that, you cannot separate them. And off the top of my head, I do not recollect. What I do know is that both the non-metadata portion of that file and the metadata portion in and of themselves are not HDF5 files. I think there are certain elements, such as I can't even remember in the case of the split, if the signature, the HDF5 file format signature, is in front of the metadata file or in front of the data file. I would have to lie. I don't know. But one of them has the HDF5 file signature, but then, unlike a scenario where you are using the SEC2 VFD, there will be a so-called driver block where the library is basically informed that, okay, you're not dealing here with a standard sec2 file layout, but you are dealing with this split arrangement, and then there are some there is some metadata that basically tells you typically the extension. You can specify a prefix or a suffix telling you something about the name of the raw data file and the metadata file to then enable the driver to locate that, and then everything is fine. Now, so if you were to load this into S3, off the top of my head, I would not know. So maybe that's where we need to talk a little more. So let's assume we've put them, we would have, let's say, 2 blobs that we just put in S3, and sort of what were you thinking of doing with them?
I was looking for the easy way to transfer or share the metadata portion without bringing along necessarily the raw data portion of it.
Okay. Yeah, you can certainly do that in the sense that right. But then if you let's say that metadata portion is typically small, you can even load that into memory.
Yes.
So then you have that in memory, but then that in and of itself doesn't help you that much, because there is something, and maybe that goes more in the direction that you want to go. I forgot in which version we introduced that, probably in one of the 110 versions. There is something called the metadata cache image.
Okay.
And the idea of the metadata cache image is basically when you are accessing an HDF5 file, so you're creating objects, writing objects, and so forth, like a cache in a regular computer. At some point, the contents of this cache will be representative to some degree of the working sets. Let's assume there's only one application or very few applications, and only one of them really dominates what goes into that cache. What you could think about doing is, at some point, that cache is warm, as people say. So it has a pretty good hit rate, or the hit rate is as good as it can be for that particular workload. And so if you transplant that idea to HDF5, you could say, okay, I have an application running with HDF5. Well, at some point, if I could take a snapshot of the metadata cache, that would be somehow representative of the working set, in the sense of the metadata that's really in use and necessary for the application to run efficiently. That if I could take a snapshot of that image, and so to speak, we once talked about the user block, for example, if I could jam that metadata cache image somehow into the file, then what I could do next time I start the application, I could open the file, and if there is a metadata cache image there, I would just read that full metadata cache image and sort of have pretty much a perfect initial state for the metadata cache. So this is something that's available in 110. Again, I will make a mental note of this, and we'll come back to that next time. But so but then maybe still, maybe I didn't fully understand. Then what? Mm-hmm.
Yes, let's at this point, let me do a little bit of required reading on the split file driver. And then between now and next week, I'll put something on the document that'll give you something to go on for next week. So this was just sort of an initial, some initial questions that came into my mind, because I wasn't too familiar with the split file driver, but it sounded sounded like it had some promise for what I was thinking. So, so I wanted to just ask it before I got too far down the road where I was just too misguided. So I just wanted to find out if I was in the ballpark. So let me read up, and then I'll give you something to go on for next week.
Great, thank you. That sounds great. Yeah. And again, you can always post something on the forum, and but putting it in the document is great.
Okay.
Thanks.
Thank you.
All right. Last week's highlights. Well, the biggest announcement was really the 1.13.1 release, and I linked here the where you can download the tarball, the release notes, and then sort of in tandem with that, we had this very interesting blog post by my colleague Jordan Henderson on the improvements. That's sort of one of the bigger portions of improvements in this maintenance release, the improvement of parallel compression, and also the there were some bugs fixed around collective operations and so forth. So if you go check out that blog post, I just have it open here. I'm not going to go through it, but yeah, they did, to confirm the level of improvement and so forth. They ran benchmarks into the few thousands of ranks. They used IOR to do collective reads and collective writes, and with compression and without compression and so forth. I think if I just select one of these figures, so yeah, I think they ran up to maybe 20, that could be 2048 maybe or something ranks. So that was pretty good, and they saw good improvements, and so that's quite an achievement. And then also, yeah, the description in the blog post, I think is very clear and nice. And one of the sort of nuggets that stuck out to me that I remembered was that in one of the previous episodes, we talked about data set allocation, and then that at least with sequential HDF5, depending on the layout, but also you can take control of when something gets allocated in a data set, whether it's a chunk or the whole data set. So there are these terms like early allocation, which means everything gets allocated when the data set is created. And there's late allocation, which means something will be allocated only on the first write, when actually a data set element is actually written or updated on such a data set. And so for parallel HDF5, meaning MPI parallel, the only option used to be early allocation, which means that the data set creation was a collective operation anyway. So when you created it, that was the time when space in the file, in the typical parallel file system, was allocated. And but now, with, at least in a case where obviously when you do compression, it's got to be a chunk data set, because you have to go send your chunks through the filter pipeline. But now with filtered, meaning chunked data sets that have some kind of filter applied, incremental file space allocation is actually available. So that was implemented. So it's no longer necessary for there to be early allocation under all circumstances. It can be incremental. So this is just a technical detail, but something that might be interesting to some folks out there. Okay. Anyway, I highly recommend you read that. Any other questions so far?
No, Gerd.
Okay, thanks. Okay, then let's jump to the forum. There was an interesting discussion around sort of data spaces and attributes and so forth. The background was that somebody wrote and said, okay, I have this multidimensional data set, and I use one large data set, multidimensional data set, to store multiple physical quantities. So the example I think the user used was a single scalar of some sort, let's say double precision floating point numbers for argument's sake, to store velocity, density, and temperature. Okay, maybe the velocity a one-dimensional velocity could be a little boring, but just for argument's sake, let's say velocity, density, temperature. And that gives you a three-dimensional data set. So they store this for a grid here, 101 times 71 times 51. And then to distinguish, that's sort of the spatial grid, if you wish, that they use to record these three quantities. Then since it's three variables here, or three quantities, velocity, density, temperature, they really sort of, stack them together into this three, that's the leading dimension, times 101 times 71 times 51 data set. And that's fine, that's perfectly legitimate and so forth. And from the description, you can infer that this data set is actually extendable also. And they do that periodically. And they also extend it sometimes, not only in the sense of that the spatial domain is potentially expanding, but also, let's say, they add another physical quantity to this, for example, let's say pressure. And so then that 3 would turn into a 4. And if you now want to keep metadata, if you wish, attached to this sort of physical or to this variable dimension, then the question is, if you store this in an attribute, or in this case, you would need either 4 attributes for 4 different quantities, or an array of at least 4 elements or something like that. But then again, depending on which way you decide to go, you have to think about how to store these quantity metadata. In the simplest case, just the symbol of the quantity and maybe the unit. So that string pair model, I think, was the use case here in this post. Store these quantity metadata somehow in an array-like attribute that you would attach to this large data set. Now, the problem is that if you made this an array HDF5 data type, so a data type of type H5D underscore array, the problem is that these elements, these arrays, they are fixed size. So once you've said, okay, it's one-dimensional, it has 4 elements, done, it's fixed. You can't all of a sudden have it hold 5 elements or 10 elements or something like that. And the other problem is that if you say, okay, I'm not going to use an array data type to represent it like that, but I'm just going to use a one-dimensional an attribute whose data space is a one-dimensional array, then the problem is, unfortunately, attributes do not have the functionality that data sets have, which is that they can be extendable, so that you can grow or shrink them if they are chunked. And since there is no chunking for attributes, that's one of the main reasons. Again, it's just an implementation choice that was made at the time. It's not something that has anything to do fundamentally with the HDF5 data model. It's just an implementation choice, and most of the time you implement things that people need and want, or that a lot of people need and want, rather than that come up occasionally but can be maybe solved with a different approach. So in light of these problems, the non-extendability of attribute data spaces, or the fixed size constraint for these array data types, there are of course other options. I mean, to me, that's always one of the interesting things about HDF5. You may not be able to do something directly as you pictured it, but there are many ways to achieve what you had in mind by just using different features. So sometimes it's a good thing if there's only one way to do one thing, but sometimes it's also a good thing that there are many ways to do one thing. And yeah, it really depends. Okay, Of course, call it the brute force solution would be to say, well, I'm still going to go with that array data type, for example, and assuming that you're not constantly adding or removing physical quantities, what you can do is that whenever you are about to add a new variable, a new physical quantity to this array, you can then just extend the underlying data sets where you store the actual measurements, let's say. But then for this attribute, you basically read it, define an array of an array data type that's at least one element larger, if not larger. You can try to sort of amortize the cost of that operation. But you would just extend the array, populate the values that you have at the one for the quantity that you just added, and then rewrite the whole attribute and do that on each dimension change. Again, if you don't do this 1,000 times per second, this is not going to be a performance problem or something like that, and it's going to be fine. It's a little inelegant, but it'll work. The second option is, okay, these array data types that I mentioned earlier, that's one way to go. There is, at least for one-dimensional arrays, there is this concept of a variable length sequence, or VLEN in the documentation, that's referred to as VLEN sometimes, data type, where, yeah, these are variable length sequences. The primary example are if your variable length sequence element type is a character, then this is also known as a variable length string. So you can store strings of pretty much arbitrary length as an element of a variable length sequence, a variable length string data type, that is. And so in this case, yeah, you could use that variable length sequence data type of type, whatever type you need. So let's say pairs of strings. And then every time you add a new quantity to that array, you would basically read the existing variable length sequence. There would be as many elements as you have physical quantities in that array. Basically add another element to that sequence and then rewrite the attribute. In this case, you don't really have to change the type of the attribute or anything, because that's the nature of a variable length sequence. Its length can change, and so just rewriting the value, everything will be updated properly in the file and so forth. Of course, for all these solutions, there is the implicit assumption that the order of the physical quantities, if you sort of traverse that leading dimension of this large array, the order of the physical quantities is the same as the order of the metadata that you will be storing in this variable length sequence. So you got to keep the two in sync, but that shouldn't be too difficult, or that's kind of the natural way of doing it. And there's at least one more way to do this, which is you can use, sometimes people call this a shared, and I put it here in double quotes because in the strict sense, their attributes are not shareable. Attributes are really HDF5 attributes, that is, are associated with a given HDF5 object, such as a group or a data set and so forth. But you can mimic, and now we are again into improvisation and mimicking things in HDF5, you can achieve the appearance of something being shared between multiple data sets or multiple objects or even groups and data sets and so forth by doing by adding a level of indirection, and that's kind of shown in this cartoon picture here. So here we have, as you can see, we have data set 1 at the top, and then below that we have data set 2, and then presumably there is this data set called data set A that, if you wish, represents the information that's considered to be shared between these two data sets. But data set 1 could also be a group, or data set 2 likewise could be a group or a named data type. It's just here happens to be data sets, but any HDF5 object would be perfectly acceptable here. And so they share the metadata that is contained in that data set, A, and the way the association between dataset 1 and dataset 2 and that dataset A gets established is basically to put an attribute, one per object, one per dataset 1, one per dataset 2, and the element type of that attribute is, as it's called here, is object pointer, or as we call it, object reference. So if I have an attribute on a data set and I see the data type of that attribute is object reference, that kind of tells my application, okay, in order to resolve, to understand what is meant here as attribute data, I have to go and resolve that reference. And then once I get a hold of that data set, by the way, data, since it's an object reference, data set A could also be a group. So again, this is all object references work with any type of object. It doesn't have to be a data set, but in most cases, it probably would be a data set. So coming back to the original example, in this case, if data set A were one of these extendable data sets, then yeah, that's exactly what the user was asking for. But in this case, yeah, the price to be paid for that is that you have to introduce object references, which in and of themselves are not really intimidating, especially since in one of the, I believe, 110 versions, we introduced object references that can refer to objects in other HDF5 files. The original implementation of object references was only available for reference in the same HDF5 file. So you could have an object reference, but it had to point to an object in the same HDF5 file. With that re-implementation or extension in, yeah, I don't remember which HDF 110 version, that limitation was dropped, and nowadays with the version 2 or 3, I forgot, of HDF5 object references, yeah, you can point to objects, so to speak, outside or in another HDF5 file. And I also can remind you that in a few episodes previous, we talked about the difference between references and links, because yeah, they in some respects they look alike, but there are some important differences. So if you missed that episode, I recommend you go back and check that out. But in this case, yeah, it's references or pointers. Okay, so long story short, I think it was a great discussion. Lots of people chimed in, and yeah, and I always enjoy that when people who have been in similar circumstances have come up with their creative solutions and so forth. And at the end of the day, there is no right and wrong here. It's really about being pragmatic and using what works for you. Okay. And then, oh yeah, we are running out of time. I'm sorry. There was another that was more maybe of a technical detail. A user had an interesting and provided an example program, so that was really great. And what he was basically doing is it looked like he pointed his script at a certain directory and then was basically locating HDF5 files. He was just looking for the *H5 extensions, locating HDF5 files, and then for each of the files, he was basically reaching into those files. So presumably they had similar profiles, similar content. He was just reaching into those files, creating dictionaries, a list of Python dictionaries, one dictionary for each file, and then basically, yeah, have like an in-memory, a cache of all the contents of these HDF5 files. And to me, that code looked perfectly sound. There was nothing wrong with it. It was just a short snippet of Python. A bit of a mystery was, though, he noticed that on a Mac OS, as he added more and more files to that directory, or as he iterated over more and more files, it just got slower and slower and slower. And he must have tried it because he said that he could not reproduce this issue under Windows with either H5Py 2.x or H5Py 3.x. And so to me, it's a little bit of a mystery. Yeah, so I don't have a Mac. I don't know what that might be. So we'll see if there's a follow-up, but it's one of the rarer cases. I have not really seen anything that this would remind me of, because as far as Python is concerned, he uses sort of enumerations and list comprehensions and whatnot, but Python doesn't do, in this case, sort of lazy evaluation or something like that, where you would rack up large memory footprints and whatnot potentially. So that's not it. Maybe there is just something either in the HDF, either in H5Py or the HDF5 library, but it must be really, it appears, macOS centric. And okay, unfortunately, that's it for today. And we will definitely come back to your question next time, but I also had prepared, and we can keep pushing this forward once we have time. I wanted to talk a little bit about HDF5 applications and clients in cloud-based environments. So I think that in a way resonates with your question, and we should definitely start with your question next time. But then if we have time, I would like to get a little bit into this and show you sort of the different arrangements and scenarios that you can have in a cloud with HDF5, with the library, with HSDS and so forth, and non-HDF5 library clients, so to speak. But that's going to be next time. And yeah, okay. I thank all for coming, and come back next week and we'll talk more HDF5. Thank you.
Okay, thanks, Gerd.
Yep, bye. Mm-hmm.